Hello children, in our earlier video we looked at examples of some sequences. We also tried to recognize the pattern in the sequences. We recognized the pattern and we also coined a general term for the a general form for the nth term of any sequence, isn't it? We try to formulate a general form for nth term. Now, here in this video, given a general form of the nth term of the sequence, let us try to list the sequence. Now, for example, look at this sequence. The nth term, let us call the nth term as xn, is given to be minus 1 raised to the power n, 2 to the power n. Now, let us learn how to list the sequence or write down the sequence given that this is the nth term. So, what would be the first term? What would be x1? X1 would be minus 1 raised to the power 1, 2 raised to the power 1, which would be minus 2 because this minus 1 is raised to an odd power, it's a negative 2. What about x2? It's going to be minus 1 squared, which is 1, 2 squared. So our second term in the sequence is going to be plus 4. So let me keep writing the sequence here, minus 2 plus 4. And what about my third term? X3 would be equal to minus 1 cube into 2 cube, right, is equal to 2 cube is of course 8 we know, and since minus 1 is raised to an odd power, we have a negative 8. So this is going to be our sequence and so on. Now let me at random find maybe the sixth term of the sequence. X6 would be equal to minus 1 raised to the power 6. So it's positive 2 raised to the power 6. What is 2 raised to the power 6? 2 2s 4, 4 2s 8, 8 2s 16, 16 2s 32. So this is going to be 64. So this is going to be, so in between terms of course we haven't calculated 64 and so on. And so this is how we are given the general form. Given this form, we can easily write the sequence. Now let us see some other examples, some more examples. Let this be the general form, 5 plus n. The nth term is 5 plus n. So what is going to be our first term? Now let me just write down, because this is a very simple calculation. Let me just write down the sequence. So if n is equal to 1, it is going to be 6. So the first term is going to be 6. Second term 5 plus 2. Second term is 7. And 5 plus 3, 8, and so on. So this is a very simple sequence. Just that we see that the difference is the same. This is what we notice here. It's plus 1, plus 1. So next term is going to be 9. 5 plus 4 is 9. That is also plus 1. Let's look at this sequence and all the other sequences which we learned in our previous video. Now, difference is not the same. The difference between the consecutive terms, whether you do the nth term minus the n minus 1th term or the n minus 1th term minus the nth term, the difference will be the same in this case, but not here. Now let me let us look at one more example of this case where the difference is the same. Say maybe this is one more example. Xn, or the nth term, is 10 plus 2 into n minus 1, right? So let's start listing. I think here also the calculation is not going to be complicated. So let us write it as a sequence. The first term is 1 minus 1, 0. So this term is going to vanish. 2 into n minus 1 is, see, if I'll just do it quickly, but you can work it out. You can pause the video and work it out for each n is equal to 1, n is equal to 2, etc. So if n is equal to 2, it's going to be 2 minus 1, 1, so 12. If n is equal to 3, we have 3 minus 1, this becomes 2, it's going to be 14, and so on. So what if n x 5? let me calculate just for x5. 10 plus 2 into 5 minus 1, which is 10 plus 2 into 5 minus 1 is 4, 18, right? So on. So you can calculate for any term this way, just substituting value of n as 1, 2, 3, 4, 5, etc. This is another sequence. Here also you see that the difference is just plus 2. I mean the common difference. Every term in the sequence differs by 2. So, just one more example to show that 10 plus or let's have it as 10 minus, right? 10 minus, just to show that these sequences can be decreasing also, not that always they have to increase, not that the sequence it can increase, it can decrease, it can also be a 0, right? So 2 into n minus 1. So substituting for n is equal to 1, 2, 3, etc. We have the sequence. For the first term, of course, is going to be 10 only. So if n is equal to 1, it becomes 0. The first term is 10. What about the second term? The second term is 2 minus 1. 10 is going to be reduced by 2, which is 8. The third term, again, it's 8 is going to be reduced by 2, isn't it? Or 10 minus 2 into 3 minus 1. Let me work it out for you. 10 minus 2 into 3 minus 1, or 10 minus 4, which is 6, and so on. So you see that the consecutive terms once again differ by 2. Of course, this time it's a negative 2. It's decreasing sequence. It's a negative 2. But the takeaway from these three examples are the difference between the consecutive terms remains the same. The common difference between the consecutive terms remains the same, right? And now at this level we are going to explore these type of sequences more. In our upcoming videos you will see these type of sequences where the common difference is going to be the same, and we have a special name for this. They are called arithmetic progressions or arithmetic sequences where the common difference is the same. These are called APs or arithmetic progressions. Let's see some more of this in our upcoming videos. I hope you understood. Thank you.